Looking up at the stars is one of humanity's oldest activities, and yet, even after millennia of inhabiting this planet, we are still unable to explain everything that surrounds us, because space, much like our oceans, remains an immense, dark territory that is difficult to explore. That is why today we are going to tell you about some of its mysteries, ranging from the well-known, such as dark matter, to more recent or less discussed occurrences surrounded by science, data, and observations, but also by an unsettling sensation, as if what makes them strange is precisely that. We cannot understand them. It is as if they were a crack in the universe, something that should not be there. Perhaps that is why, although everything you are about to hear in this video has scientific foundations and we are not talking about monsters or alien invasions, these mysteries can feel just as fascinating as they are terrifying. So, get comfortable and turn off the lights, because these are 7 unsolved mysteries of space. How are you? Good morning, afternoon, or evening. And here we begin. The signals from a dead galaxy. We start this list with one of the most baffling phenomena that humanity has been able to detect in the modern universe: fast radio bursts, or FRBs. These, as their name implies, are extremely brief radio bursts, with durations ranging from microseconds to milliseconds, which have the capacity to release a tremendous amount of energy in an instant to such an extent that these flickers can exceed what the sun emits in an entire year. We have been recording them for several years, and although today we understand much more about their behavior, their origin remains a mystery. For a long time, the most widely accepted explanation was that many FRBs are related to magnetars neutron stars with very intense magnetic fields that usually form after the explosive death of massive stars. This fits quite well with a pattern that repeats in observations. A large part of the detected bursts tend to come from young galaxies or those with active star formation, places where stars are still being born, where supernovae occur, and where the type of environment that could give rise to these extreme objects exists. In fact, although there are thousands of registered FRBs, only about 100 have been precisely located to their host galaxy, and the majority of those galaxies coincide with this profile, active, and with significant star formation. However, on the 9th of February 2024, something happened that forced the scientific community to rethink several of these ideas. That day, the Canadian Hydrogen Intensity Mapping Experiment, better known as CHIME, detected a new signal that would later be catalogued as FRB 202402009A. What at first seemed like an isolated flash soon made it clear that it was not a single event, because over the following months, the signal appeared again. Between February and June 2024, 22 bursts from the same origin were recorded, enough to confirm that it was a repeater, a type of FRB that does not die after a single emission, but returns again and again. Furthermore, the behavior of this burst was especially striking due to its evolution. At the beginning, its appearances were sporadic, with bursts separated by several days, and a prolonged silence period of about 3 months was even reported. But in June 2024, the activity skyrocketed, as 17 of the 22 bursts occurred in a single month, and on June 29, the system reached a particular peak when the experiment detected 5 bursts in a single day. This type of variation going from apparent calm to an explosive stage in a matter of weeks is not new. It has been seen in other repeaters, but it remains one of the most intriguing aspects of the phenomenon. The problem with FRBs, however, is not only detecting them but knowing exactly where they come from. It is one thing to record the burst and another very different thing to identify the exact point in the sky from which it came. Without that precision, it is difficult to link it to a particular object or a specific galaxy. To solve this, the experiment relies on a key system, complementary stations known as outriggers, which are small arrays that act as an extension of the main telescope and allow for localizations via interferometry, comparing minute differences in the signal's arrival. In the case of FRB 202402009A, several of these signals were also captured by an additional detector placed tens of kilometers from the main observatory. Thanks to that, astronomers were able to locate its origin with enormous precision, narrowing the margin of error to a tiny point in the sky. And that was when the real twist of this case appeared, because by pointing optical telescopes at the site, the team managed to associate the signal with a specific galaxy with a high level of confidence, 99%. The detail is that the signal did not come from a normal galaxy for this type of phenomenon. It came from an elliptical galaxy, one of those ancient galaxies that are no longer forming stars. In other words, a dead galaxy. And yet, from there, something was coming out capable of launching bursts of energy that traversed the universe. Astronomers calculated that the galaxy is more than 11 billion years old. It is about 2 billion light-years from Earth, and it is gigantic, so massive that it far exceeds what is normally considered a typical host for a signal like this. Furthermore, in a galaxy like that, where no new stars have been born for eons, it would not make sense for something like that to be happening. But the strangest thing was not even the type of galaxy, but the exact location within it from which the signal came. It did not appear near the center, where there is the greatest concentration of stars, and where important things normally happen. This burst came from the outer limits, from the periphery, in an area where there should almost be no activity. To give you an idea, it was so far from the core that it was practically as if the phenomenon did not come from the galaxy itself, but from its margins, and that detail turned it into one of the most displaced signals ever registered with respect to the center of its host galaxy. It was then that researchers began to consider another possibility, that perhaps it did not come from a young star, but from something old, something very, very old. One of the strongest hypotheses is that the source is related to a globular cluster, which are basically dense groupings of ancient stars that tend to be right in the outer regions. And in a place like that, instead of new phenomena, different things could occur. Interactions between stellar remnants, collisions, mergers, or compact objects that have been there for billions of years. This idea is not just a theory thrown into the air, because there has already been a previous case. FRB 2020e, located in a globular cluster on the edges of the M81 galaxy. And while it was not exactly the same situation, the coincidence is unsettling, since these are signals that appear far from any area where stars are being born, in places dominated by old stellar populations. And that opens up a possibility that changes everything. Perhaps there exists a family of FRBs that are not born like the others, that do not follow the same path, and that form under completely different conditions. For now, there is no definitive answer as to what exactly FRB 202402009A is. We only know that it forced us to ask ourselves if we have spent years trying to explain a phenomenon with limited ideas. But that is precisely the most fascinating thing about our universe. Every time we take a step that seems to bring us closer to a new answer, several paths open up with many fascinating possibilities. Dark matter. When we talk about dark matter, it is easy to believe that it is one of those concepts born in science fiction, but the reality is that it emerged from a very specific premise. The universe, as we observe it, should not behave the way it does. Something simply does not add up, and for decades astronomers have hit the same wall over and over again, with the feeling that there is something else, something we are not seeing. And that is where dark matter enters the scene. In simple terms, it is a form of invisible matter, as it does not absorb light, nor does it reflect it, and it does not emit it. Furthermore, it leaves no trace in the electromagnetic spectrum, and for that reason, it is not possible to observe it as we do with stars, nebulae, or galaxies. However, just because it is invisible does not mean it is not there. What gives away its presence is its weight, its gravitational presence, and the way it seems to affect the movement of entire galaxies, as if it were pulling them from outside the stage. In other words, we cannot see it, but we do see what it causes. And for that reason, despite how strange it sounds, dark matter is considered today one of the key pieces of the current cosmological model. Everything we know, planets, stars, gas, dust, ourselves, all of that represents only a small part of the universe's content, while the rest would be dominated by components that we still do not fully understand, and among them is dark matter, which would have an enormous role, making up the majority of the matter there is, while dark energy would complete the largest portion of the total. From this perspective, we live in a cosmos where what is visible is barely the tip of the iceberg. The story of its discovery began in the 1930s, when astronomer Fritz Zwicky was studying the Coma cluster and noticed something that did not make sense on paper. The galaxies within the cluster were moving too fast. If the only available gravity was that of visible matter, that cluster should not stay together. It should have fallen apart over time, like a swarm dispersing, but it did not. It was as if there were extra mass, giving it the force necessary to keep everything in its place. Zwicky initially called it Dunkelmaterie, dark matter. And although for a time it sounded like a strange idea, the problem was already posed. Decades later, in the 1970s, the topic exploded with force for an even clearer reason: the rotation of spiral galaxies. Logic indicated that the further you are from the center, the slower you should rotate, just as happens with the solar system. But when the speeds of the stars at the edges of these galaxies were measured with precision, the answer was unsettling, for they were not decelerating as they should. They were moving too fast, as if the galaxy had much more gravity than its light showed, as if around everything visible there existed an enormous invisible halo, dominating everything. That was where the name of Vera Rubin became fundamental, because her observations reinforced the idea that this was not an error. It was a pattern. Over time, dark matter stopped being an isolated explanation and started fitting into many different pieces. And one of the most impressive proofs came from the phenomenon of gravitational lensing. General relativity already stated that gravity can curve space-time and deflect light. So, when astronomers observe distant galaxies deformed, stretched like arcs, or distorted by intermediate masses, they are actually seeing a map of gravity, and that map, time and again, suggests that there is much more mass present than what corresponds to the visible. Of all these pieces of evidence, one became iconic: the bullet cluster, a gigantic collision of galaxy clusters. In this crash, the hot gas, which is normal matter, slows down and is left lagging behind due to the violence of the interaction. But most of the mass measured by the gravitational lens appears separated, as if it had traversed the impact almost without touching anything. For many scientists, this is one of the most difficult signals to explain if dark matter did not exist, because it seems to show a clear separation between visible matter and the true center of mass. It is as if the universe left the footprint of something invisible, moving in silence but carrying the weight of everything. And yet, the most frustrating thing is that we still cannot catch it. The most common explanation is that dark matter could be composed of a subatomic particle that we do not yet know, something that barely interacts with common matter, except through gravity. For years, one of the favorite candidates were WIMPs, weakly interacting massive particles, imagined as ghosts traversing the cosmos without leaving a trace. Another strong candidate are axions, hypothetical particles much lighter that were born as a solution to particle physics problems and are now considered a quite serious possibility. And in more recent years, an even more unsettling idea has gained strength: that dark matter, or part of it, could be composed of primordial black holes formed in the first instance after the Big Bang. They would not be black holes born from collapsed stars, but objects that emerged when the universe was so young and violent that certain regions could become dense enough to begin to collapse on their own. But the universe also throws out strange clues, as if it were playing with the idea of contradicting what for us are its rules. A famous example is NGC 1052, DF2, a galaxy that was described as an oddball, an anomaly that seems to have very little dark matter. And that is a scandal because modern theory insists that galaxies form within dark matter halos, as if this halo were the invisible mold that allows normal matter to gather and ignite stars. But that is why finding a galaxy without dark matter is like finding a body that has no shadow. The debate became intense because everything depended on something critical: its real distance. If it was closer, perhaps it was all a calculation error. But the deepest observations with Hubble reinforced the idea that, at least in that case, the galaxy does seem to be strangely devoid of dark matter. And it would not be the only one, because DF4 has also been presented as a galaxy with the same rarity, although some suggest that its dark matter could have been stripped away by tidal forces. And that does sound strange. Cloud 9 takes it even further, for it is the opposite case. Instead of a galaxy with little dark matter, they talk about an object that could be dominated by it, a gas cloud without stars, a kind of failed galaxy, a block of neutral hydrogen that exists as a compact structure sustained by gravity that the gas on its own cannot explain, as if the invisible scaffolding were there, but the galaxy had never finished being born. There is still much caution and alternative explanations, but the idea that there exist nearby structures, without light, without stars, practically invisible, which can only be detected because there is something that keeps them together, is simply unsettling. And in the end, that is the true cosmic horror of dark matter. It is not a monster, nor is it a supernatural force. It is something that is perhaps worse than that: the certainty that we cannot see most of the matter in the universe, that the complete structure of the cosmos, the way galaxies are born, And how the universe is organized depends on something that traverses reality in secret, something that has been there since the beginning and that even today, in the era of space telescopes and underground detectors, remains a gravitational ghost, a gigantic piece that controls the landscape without ever showing itself directly, and that perhaps we will never be able to understand in its entirety. The runaway black hole. A supermassive black hole is not just anything. We are talking about objects that weigh millions or even billions of times more than the sun, and that normally are found at the center of a galaxy, anchored there like the dark heart of an entire stellar system. That is why the idea that one of these monsters could be ejected, torn from its home, and launched through space sounds like an exaggeration, at least until the evidence begins to form before our eyes. In 2023, the Hubble Space Telescope captured a trail, a thin and very long line of stars being born in a row, as if something had passed through the gas of a galaxy, leaving a luminous scar behind. The structure measured around 200,000 light-years, double the diameter of the Milky Way, and at the end of that path there seemed to be an even more unsettling clue, a bright point of ionized gas, as if a brutal impact were occurring there. The initial proposal was immediate and explosive. This seemed like the trail of a runaway supermassive black hole, one that would have traversed a gas halo at an absurd speed, compressing it, heating it, and causing the material to collapse to form new stars in its wake. It would not be a black hole devouring everything in its path, but one moving so fast that it would not even have time to feed. A kind of gravitational bullet. The strangest thing about this is that, according to this hypothesis, the way the black hole would have escaped would be through an extremely rare cosmic choreography, a kind of billiards game between three supermassive black holes. What would happen is the following. First, two galaxies merge and their black holes end up orbiting as a binary system. Then, a third one would arrive, and the balance would break. In that chaotic configuration, one of the three can be shot out, escaping the galactic center, as if it had received an invisible kick. It is the type of event that seems improbable, but which simulations have been saying for decades could happen, although almost no one expected to see it. The detail is that story, as fascinating as it may be, was too perfect to be accepted without resistance. And as always happens in these types of cases, the scientific community was divided. Some were excited, but others were suspicious, and several looked for simpler, less cinematic, and more plausible explanations. But it is here that the unexpected twist came. For other teams proposed that the trail of stars was not really a wake, but something different, perhaps even more deceptive, a flat galaxy without a bulge, observed from the side, which would make its shape look like a long and bright line. According to those analyses, the size, the quantity of stars, and above all the observed movement, would fit surprisingly well with what is expected of a rotating galaxy. They even compared this object with a known galaxy in the local universe, IC 5249, an example of a thin disk, and found similarities that did not seem like a coincidence. This meant that it could not be an extreme phenomenon, but a strange interpretation of something really common. For a time, the story remained in that ambiguous terrain, although both scenarios could be correct. In 2025, the James Webb Space Telescope found something decisive. At the end of that line of stars, there was indeed a black hole that would be moving at about 1,000 kilometers per second, a speed sufficient to escape the gravitational grasp of its galaxy, and also cause that line of stars. What was confirmed with this was not only the existence of a black hole out of place, but the proof that one of these supermassive cosmic monsters can be torn from its galaxy. And if there is anything more dangerous and terrifying than a black hole of that size, it is one that moves through space. If you are enjoying this content, we remind you that we have much more on our other channels. In Octambulos Podcast, we talk about paranormal topics and true crime, like in a chat between friends. In Historias de Mundo Creepy, we tell the most chilling stories experienced by our audience. And in Creepy Pastas de Mundo Creepy, we narrate terrifying stories written by us. Everything is available both on YouTube and on your favorite podcast platform. Jumbos, the wandering planets. There are occasions when the universe decides to remind us that everything we have established as rules are merely assumptions, and jumbos are a clear sign of that. At the end of 2023, in the Orion Nebula, astronomers stumbled upon something that was not only strange but directly difficult to understand. Dozens of giant worlds the size of Jupiter wandering free through space without orbiting any star. And not only that, they were in pairs, two planets together orbiting one around the other, as if they were a miniature solar system, but without a sun. A duo condemned to float in the dark as if they had been expelled from normal reality and had remained united solely by gravity. They received the name jumbos for Jupiter mass binary objects, that is, binary objects of mass comparable to Jupiter. They were found in the Trapezium cluster, a region within Orion where stars are born, a young, chaotic place with barely 1,000,000 years of age. And there, in that stellar nursery, the James Webb Telescope detected hundreds of planetary mass objects, many of them as small as half the mass of Jupiter. But what broke the board was discovering that a part of them was not alone. Near 9% appeared to form wide binary systems, separated by enormous, almost absurd distances, comparable to the distance between the Sun and Neptune, or even much more. The problem here was very simple. According to everything we understand about space, these objects should not exist, at least not with that frequency, and not in that place, or simply not like that, because if we have learned anything by studying stars, brown dwarfs, or planets, it is that nature has a very clear tendency. While the smaller an object is, the less likely it is to form stable pairs. Massive stars tend to be born accompanied. It is common for them to exist in binaries or multiple systems, but when you lower the mass range of objects to smaller ones, this multiplicity collapses. Brown dwarfs rarely have companions, and in the planetary range, it is assumed almost never. So, what is happening in Orion? On one hand, these jumbos could seem like an extreme version of something we already know. Wandering planets, worlds that were expelled from their systems by violent gravitational interactions, planets that, so to speak, were kicked out of their home and left wandering like interstellar orphans. That, in itself, is not a new mystery. The problem is that here we are not talking about one planet, but about pairs, and expelling a planet is already a brutal event, so expelling two at the same time, and having them remain gravitationally united, sounds like wanting to throw two glass cups on the floor and expecting them to land perfectly fitted, without breaking. Still, an explanation that gained strength suggests precisely that jumbos could have been born around a star, and then were expelled together. A team of researchers proposed a concrete scenario, that in dense clusters where stars are relatively close to one another, gravitational encounters can be frequent, almost inevitable. In this chaos, a young planetary system could be interrupted by the passing of another star, and in certain specific configurations, two giant planets could shoot out in a pair and remain trapped with each other, orbiting in the void. It would not be magic then. It would be pure dynamics, but also a kind of astronomical accident. Supercomputer simulations of the N-body type showed that under correct conditions, a close stellar encounter can expel these pairs without breaking them immediately, thus creating wandering planetary binaries that wander through space together. The idea is so strange, but so elegant, that if it were true, it would completely change our understanding of planetary evolution, because it would imply that the universe is capable of creating planetary systems without stars. But, yes, not everyone is convinced by this hypothesis, and it is precisely here that the mystery gets even better, because we are not facing a closed story, but an open debate. A possibility perhaps even more unsettling is that the jumbos were not even expelled from anywhere, but were formed on their own as if they were failed stars, objects born directly from the collapse of small clouds of gas, but with a ridiculously low mass. The problem here is that according to current models, this has a limit, a theoretical floor below which this type of collapse should no longer happen, and these jumbos would be just below that point, as if they had slipped through a crack in the rules that we have. More strange mechanisms have also been proposed. For example, the possibility that cosmic rays influence how gas behaves within a nebula, helping certain regions to become unstable enough to collapse, not to form stars, but to give rise to bodies the size of enormous planets. In other words, the universe could be manufacturing wandering planets directly. But even if we accept this idea, there remains an unsettling part. Why do they appear in pairs? If they were born that way, one would have to explain how binary systems form in a mass range where they are not supposed to be common. And if they were expelled from a system, then the scenario is just as strange, because it would mean that the cosmos can throw out two gas giants together without separating them. And well, then here comes the third possibility, perhaps the most frustrating of all, that maybe they are not even planets. There are astronomers who have pointed out that in a region as loaded with dust as Orion, there can be background stars that look weaker and redder than normal, enough to appear as planetary mass objects. It has even been suggested that several candidates could be real, and that perhaps only a few cases are truly authentic, but that does not reassure anyone, because if even 2 or 3 are real, it is enough to break something important that we thought we understood. And there is the true point of this mystery. We do not know what we are seeing, whether they are expelled planets, planets born alone, or something that simply does not fit into any category yet. Tabby's star. The universe moves, changes, ages, and collapses. But still, most things follow clear patterns. A star is born, shines, maintains stability for millions or billions of years, and when it changes, there is usually a reason that we can trace. But from time to time, a case appears that not only breaks this pattern, but also becomes quite confusing. That is the problem with Tabby's star, also known as KIC 8462852 or Boyajian star. It is a stellar system located in the constellation Cygnus, about 1,470 light-years from Earth. It is not a star visible to the naked eye. You need a telescope and a dark sky to locate it. And yet it ended up becoming one of the strangest phenomena that has been recorded in recent years. The system is composed of an F-type star, similar to our Sun but hotter and brighter, and a smaller companion, a red dwarf that orbits at an enormous distance. Compared to our solar system, it would be like putting it hundreds of times further away than Jupiter. Until there, nothing strange. The detail appeared when the Kepler Space Telescope, designed to detect exoplanets and seeing minute changes in the brightness of distant stars, found in this star a behavior that did not fit any template. Tabby's star was not just dimming, but it was doing so irregularly and without a clear pattern. Under normal conditions, when a planet passes in front of a star, the brightness drops a little, around 1%, and that drop repeats like a clock. But in this case, Kepler recorded gigantic drops, some of up to 22% of the brightness. To put it in perspective, a planet the size of Jupiter could barely block around 1% of a star. This means that what was happening in front of this star was not a common planet. It had to be something much bigger, or many things at the same time. Perhaps something with a shape so chaotic that it seemed like a cloud or a swarm orbiting without order. The worst part of all is that it had no rhythm. There were 2 enormous events separated by almost 2 years, as if the star had been covered by something immense that returned much later. And between these 2 events, minor and irregular drops appeared. Kepler was seeing how this star lost light, regained it, and lost it again, as if someone were moving shadows in front of it, but without a pattern that could be anticipated. In 2015, astronomer Tabby Boyajian and her team published the study that made the case explode, and with it came the nickname that summarized it very well, the What the Fuck Star, or the What the Fuck Star. But the acronym actually stands for Where the Flux, making a curious play on words. From there, the phenomenon became a perfect storm, because when science does not have a clear answer, the internet begins to fill that empty space with hypotheses. For a time, one of the most commented ideas was also the most striking: an alien megastructure, something similar to a Dyson sphere, that is, a set of gigantic structures orbiting a star to capture its energy. This seemed to fit with the size of the light drops observed. The problem is that the explanation had an inevitable consequence. If something is blocking so much light, that energy does not disappear. It would have to manifest somewhere else in the form of heat. That should produce an excess of infrared radiation around the star. However, the observations did not find that lost heat, and the hypothesis began to lose force. Still, the case did not die out. Although the idea of the alien structure was becoming less and less likely, the mystery remained intact. And so other, more realistic explanations began to gain weight. One of the first was that Tabby's star was being covered by a swarm of comets that were fragmenting a cloud of icy bodies and dust moving in strange orbits. That could explain the deep and disordered drops in light. But it also had an important problem. To block so much brightness, huge amounts of comets would be needed, more than are usually considered reasonable. Another hypothesis proposed something similar, but instead of comets, it talked about extremely fine, almost microscopic particles forming an irregular ring around the star, an uneven ring, like a poorly hung curtain, capable of letting light pass in an unpredictable way. This idea gained strength when later observations showed a key detail. At some moments, the star darkened more in certain colors of light than in others. That usually happens when what blocks the light is not a solid object, but diffuse material like dust. But dust did not solve everything either. If there is dust, it has to come from somewhere. That is why scenarios of massive collisions between planets were explored, as if a world had been destroyed and had left enormous clouds of debris. The problem is that an event like that should also leave a clear signal of heat in the form of infrared radiation, which did not appear. Then there also arrived an even stranger proposal that in 2019 gained quite a lot of attention. The possibility that the phenomenon was caused by fragments of an orphaned exomoon, a moon torn from its planet that would be disintegrating and leaving remains in chaotic orbits. And as if this were not enough, the case became even more unsettling when some researchers suggested that Tabby's star might have dimmed slowly over decades. That idea remains in debate because old data is not always reliable, but it poses a quite intriguing scenario. The problem might not be around the star, but inside it. Perhaps something inside it is causing these erratic changes, something that we simply cannot understand or study yet. Years after its discovery, the hypotheses about Tabby's star continue to accumulate, but none fit completely, making it one of the most mysterious stars in our known universe. Planet 9. For years, the planet has been one of the most intense debates within modern astronomy. We are not talking about a confirmed planet and neither about an official discovery, but about a possibility. The idea that very far from Neptune there exists a massive world, hidden in the darkness, molding the solar system without anyone having seen it. And here's the detail that makes everything more interesting. This planet has not yet been observed. There are no photos, images, and therefore no confirmation. The only thing that exists is a suspicion based on gravity, a kind of invisible footprint that appears when certain objects behave as if something were pushing them from far away. This hypothesis gained strength in 2016 when astronomers Konstantin Batygin and Mike Brown proposed that some icy bodies of the Kuiper Belt, a region beyond Neptune, showed orbital patterns very difficult to ignore. They are extremely distant objects, with rare, elongated orbits and orientations that seem to repeat more than they should by simple chance. According to their interpretation, that alignment had a reasonable explanation, a still unknown planet that would be shepherding those bodies, that is, guiding them slowly with its gravity. If this planet exists, it would not then be a piece of lost rock. The calculation suggests something big, a super-Earth or a mini-Neptune, a world with a mass approximately 5 to 10 times that of planet Earth. And the most unsettling thing of all is its distance, for it would be so far that it could take between 10,000 and 20,000 years to take a single lap around the Sunday. In other words, it would be a real planet, but living where the solar system almost dissolves into the cold and the darkness. And so here is where the big question appears. If this planet exists, why haven't we found it? And the answer is that searching for Planet 9 is like looking for something black inside a sky that is already black. At that distance, it would reflect very little sunlight and would look too dim, even for powerful telescopes. Furthermore, the problem is not only seeing it, it is also knowing where to look. The sky is too large a place to point at random and hope to be lucky. Still, this mystery has not died because over time, clues have emerged that keep this suspicion alive. One of the most striking appeared when a team analyzed infrared observation archives, comparing two large maps of the sky separated by more than 2 decades. The logic here was simple. If Planet 9 was there, its movement would be very slow, but it should be noticeable if you compare an old record with a more recent one. And in that search, a candidate appeared. According to the analysis, there would be an object that in 1983 is seen in a position recorded by an infrared satellite, and that in later data appears at another point nearby within the range of displacement that could have occurred with the passage of time. It would not be a fast movement of a nearby object, but that minimal displacement that you would expect from something that is at hundreds of astronomical units of distance. The weirdest thing here is that if the candidate were real, not only would it be far away, but it could also be enormous. The estimate based on its infrared brightness suggests that it could have even more mass than Neptune itself, and that would clash with the most popular idea of Planet 9 as a moderate super-Earth and would open 2 equally unsettling possibilities. Either the phantom planet is bigger than we expected, or we are seeing something totally different that we have not identified well. But for now, the evidence remains incomplete. Detecting a point in 2 surveys, separated by decades, is not enough to reconstruct an orbit. To confirm it, modern observations would be needed capable of finding it again, taking into account that since the last record it could have moved enough so that the search region is enormous. That is why the planet continues to be something so controversial. There are scientists who believe that the anomalies can be explained without the need for a hidden planet. The main argument against it here is a very simple and dangerous one: observational bias. We only detect a minimal fraction of these remote objects, and we almost always find them when they are at the point closest to the sun, when they are brighter and easier to track. And this can create false patterns in a sample that is too small. In fact, even among those who support the hypothesis, many admit that the topic is at the limit. There are those who believe that the evidence is truly accumulating, but there are those who think that the enthusiasm got a bit ahead of itself, for the debate is maintained because if the planet exists, yes, it would be a gigantic discovery, something capable of rewriting the history of the solar system. Furthermore, there is a curious detail. In other stellar systems, the most common planets found are precisely intermediate worlds, bigger than Earth but smaller than Neptune. And in our solar system, nothing like that exists. Therefore, the existence of Planet 9 would fill this gap and would make our neighborhood look less strange in comparison with what is out there. In fact, what makes this case even more interesting is that the new generation of observatories will map the sky in a repetitive and systematic way with a depth that was previously impossible. That is to say, we are very close to a decisive stage. We would no longer be searching with a flashlight, but we would review the same sky again and again until something that moves slowly no longer has a way to hide. And if Planet 9 is there, sooner or later we will see it. And if it is not there, we will also know it. And that would be just as interesting and perhaps unsettling, because it would mean that the strange patterns of the Kuiper Belt have another cause that, in fact, we are not yet capable of understanding. The cold spot. There are scars in the universe that are not seen with the naked eye, but that have been telling astronomers for decades that something does not finish fitting. One of the most unsettling is hidden in the oldest signal that we can observe, the thermal echo of the Big Bang, the first light that was left free when the universe could not yet harbor life. That anomaly is known as the CMB cold spot, or the cold spot of the cosmic microwave background. The CMB is, in essence, fossil light, radiation that was released when the universe was barely 380,000 years old, in an era when everything was a hot mixture of particles that did not let light pass. With the passage of time, the universe expanded and cooled. The first atoms were formed, and the radiation was left free to travel. That light spent billions of years stretching until it became microwaves, and today we measure it with a temperature close to 2.7 Kelvin, almost absolute zero. When scientists make CMB maps, the image looks almost perfect, like a uniform background. Only small variations appear, zones just slightly warmer or colder than the average. These differences are normal and represent the first irregularities of the universe, the seeds of current galaxies and clusters. The problem is that there is a variation that stands out too much. The cold spot is not only colder, it is also too big. Measurements show that that region is about 70 microkelvins below average, but the most striking thing is its size. It covers about 5 degrees of the sky, an enormous extension for this type of fluctuation, which is normally much smaller. In other words, it does not look like a simple statistical detail. It is an entire region of space that feels out of place. It is located in the southern hemisphere of the sky in the direction of the constellation Eridanus, and that is why it is usually related to the so-called Eridanus supervoid, a possible gigantic region with very little matter in that same direction. The unsettling thing is that it is not an error. It was detected first by the WMAP satellite and confirmed later by the Planck satellite. It does not disappear when the maps improve, nor is it corrected with technical adjustments. It is really there. So, a quite interesting question arises. If it is not a measurement failure, then what is it? In cosmology, it is expected that the universe be, on average, quite uniform, on large scales, with small imperfections distributed in a normal way. The cold spot, in turn, seems like an anomaly that is too intense. Furthermore, when one speaks of temperature in the CMB, one is not talking about literal heat. What we see is the effect of gravity on light. The regions with more matter curve space with greater force, and light loses energy when escaping those zones. This phenomenon is called the Sachs-Wolf effect. In this case, there is another even more important effect, the integrated Sachs-Wolf effect. ISW. This occurs when the light of the CMB traverses large structures of the universe like galaxy clusters or enormous voids, while the universe itself continues to expand. In a stable universe, light would lose energy when entering a void and would recover it when leaving. But the universe expands in an accelerated way, which alters this balance. The result is that light can leave a void with less energy than it should, and that makes that region look colder. Here enters the best-known hypothesis. The cold spot could be caused by a cosmic supervoid between us and the microwave background. A supervoid would be a gigantic region of the universe with very little matter, an enormous hole in the distribution of galaxies. In cosmic maps, it would be seen as a zone where there are fewer galaxies than expected. For years, different teams tried to verify this idea. Some studies found a real decrease in the number of galaxies in that zone of the sky, and the existence of a colossal void with a size of hundreds of millions of light-years was proposed. But here, a problem appears. Even if that supervoid exists, it might not be enough. Analyses indicate that a supervoid could explain only part of the cooling observed. It might not be large, deep, or have the right shape. And furthermore, these studies are always limited by few data and misleading statistical effects. That is why the mystery remains open. Over time, the cold spot gave rise to more radical theories, from defects of the primitive universe to collisions between other universes. Although these ideas have mathematical foundations, none has managed to explain the phenomenon completely. The cold spot does not invalidate the Big Bang or modern cosmology, but it remains as an anomaly in the oldest image of the universe. Perhaps future observations will explain it almost completely, or perhaps it is a real clue of something that we still cannot understand. The unsettling thing is that it is not in a remote place in space, but recorded in the first light of the universe as an absence that remains without an answer. Thank you very much for subscribing, leaving your like, and following us on social media. We hope you have enjoyed these mysteries of the universe. Without further ado, I say goodbye. See you later. Amen.